Hello, welcome to Anson Griffin's Location series of YouTube tutorials featuring MATLAB. Today we're doing a rather interesting one, looking at a hyperspectral data set, and we're using SVM to classify the various data sets. Now, just before we do anything else, I've clearly identified in the code this work is not my own, so I took it from there. That's the main one. I also took the data set can be found there if you want to download it yourself. So you have to download 3 files here. And just one other thing that I mentioned, a 2D Gaussian filter, and I just copied and pasted and into the comments there, and that's from there. So I just took, if I just scroll down a bit, the bit that's highlighted there, I took that. So just to give due credit to everybody. So I ran it in, there's the code just there. I ran it and exported it to Word because it's a bit more readable. So we're going to look at it in Word. Okay. So I'm not going to go through it line by line. So you have a sensor, the Indian Pines data set, and so you run it over, and we have some water bands there. We'll get to that in a second. And these are the different classes here. And with the number of samples here on the right. So there's the RGB image, the ground truth. That's there. I assume you know what the ground truth is. It would be where the person has indicated, what crop is lying in what particular bit of the RGB image. So in this, just in this example, so this is the 3 objectives we're going to get. Pre-process hyperspectral data using the Gaussian filter, perform a classification using a support vector machine, and display the results. So we've been looking at Hypercube the last few times on MATLAB Monday. I have a Twitter site, and we went through some of those there. There, we load up the data set with the ground truth. GT label is ground truth label, and the number of classes is 16. We remove bands, so there just the water absorption bands there. And then we just do a colorize method there. Okay. Next thing here, you apply a 2D Gaussian filter. I mentioned before from that site in Edinburgh, it gave the function, and it's just sort of like a blurred ever so slightly. Okay. Like an averaging filter. So there's the IM Gauss filter. That's just doing it there. And there we convert them to grayscale in those 2 lines there. Okay. Over here, prepare the data for classification. So not going through it line by line. We reshape the data. We get the vector of the labels, and then we get the locations and the class label there. CV partition, and you can see up there if you want more about CV partition, it will come up. So there we are, we have a training percentage there and a holdout, etc. Split the ground truth into training and testing, and then we classify here using the SVM. We run through it here, and we get the classification map. We do a figure, and we get the output, and that'll be on the last page. And there we are. So there's the RGB image, there's the ground truth map, and there's the SVM classification map. I went a little quickly there, just to go back for just 1 sec. The overall accuracy here, sorry about that for going too fast, is just a little shy of 97%. Okay, so hope that was all right, and hope I didn't go too quickly. I sort of assume that you have a fairly good idea of what's going on, and thanks very much for listening.